at these points, the radiator turned down for just too long for my apartment to keep it at temperature. So there's no more heat in the radiator, the temperature drops. This indicates the necessity for the other half of our system, which is the fact that this control system has a wireless radio built into it. So we can communicate that temperature data around the building and to the boiler room. So what would the system look like with our system, what would this building look like with our system installed? You have an enclosure on every radiator, and now in apartment B, which has that bad insulation, as apartment A and apartment C gets the room temperature first, the heat transfer shuts down because we shut that fan down. And now apartment B approaches that temperature and gets there fine. We actually see more efficient heat transfer past those hot apartments to cold apartments because when heat comes into these radiators that don't have that insulation problem, they actually can't leave that enclosure because they can't leave. So the heat's constrained to the system, and this fluid that leaves the radiator is actually warmer. Eventually, that heat gets more efficiently transported to the apartments that need it. We also have no unnecessary boiler firing because when all these apartments hit their set point, it communicates that back to the boiler room, and it tells it to shut down. It no longer needs to burn fuel. So the combination of this wireless capability with the fact that we can eliminate overheating combines to save a ton of energy. One more thing we can take with this is the fact that we're constantly measuring the temperature of these apartments. So if we can record and see that apartment B's temperature drops much faster when it's not heated than other apartments, that's actually indicative of a problem with the insulation of that apartment. If we can tell the building owner that if they're going to spend any money upgrading this building, it's going to be most efficiently spent upgrading the envelope of apartment B. So how do we save money for people? How much money do we save? And I started estimating that the average apartment in the New York metropolitan area is 700 square feet and costs $1,600 per year for heat. Readingablocks.org, amongst other sources, claim that between 15 and 20% of the energy is wasted because of overheating and venting. And 3.2 million people have, 3.2 million apartments in this New York City metropolitan area. 2 million of those are in buildings with 5 more units. That's our target demographic. And conserving this 15% of the money we spend on heating is equivalent to $480 million every year, which is such a large number, it's almost unbelievable. That's equivalent to 500,000 cars being taken off the road every year, just in the New York City metropolitan area. And it breaks down to $240 per apartment. So when we designed this system, we tried to make it as low cost as we could. And we got it down pretty far. Each enclosure costs $36. That's including the wireless radio, the control system, the enclosure material, the sensors, the fans, etc., plus money to manufacture it. So $36 is pretty cheap. So 3 of those is $108 because the average 700 square foot apartment is 3 radiators. We're assuming it's going to cost some money to install them and to make sure they're working. The installation is, I think, extremely easy. And though these numbers are not set in stone, our company is only 2 months old. We're going to do a pilot study to actually get as much data as we can, which will more accurately set those costs. Using these conservative numbers, I want to show you that RadLab can be financially successful. Using these numbers, the payback period is less than 1 year for the customer, which is pretty amazing. And year 2, they obviously make more money. Oh, one important thing I need to mention is the fact that we're charging $20 per enclosure per year. And that is going to be because we want to capture the tail of the value curve, because every year after this, they're going to be saving money. We want to take some of that. And in exchange, we'll offer those data analytics I described, as well as software updates and maintaining the hardware, particularly the hardware that interfaces with the boiler. So using these numbers, RadLab will make this much money. The first year, we're going to do a pilot study with Columbia University, actually. We met with them on Tuesday. I'll describe that in a minute. It's going to be a small number of installs, 200 installs. It's about 600 enclosures. And using that, with that number, we would make $20,000. The real value in that pilot study, though, is the data we're going to be collecting. Columbia University has identified 2 buildings that are identical, and we're going to install our system in 1 building and lace both buildings with sensors. The data we get from that will show how well our system works, and we will hope to use it to show the system to a much broader audience with the data to back up the fact that it works. In year 4, if we reach 10% market penetration in the New York City metropolitan area, that's 200,000 installations. That may seem crazy, but there are very large building management firms in New York City that actually have tons and tons of customer buildings. And so getting in with a few of those management companies actually could get us these numbers. We make a profit of $20 million. And keep in mind that when we make a profit of $20 million, that is, we never charge more than the customers save. So the customers save $60 million when we make $20 million. There is an existing market that's close to what we are going after. It's the thermostatic radiator valve market. Thermostatic radiator valves go on your radiator, and when the room warms up, they shut down the valve. They do increase the comfort for tenants, but they actually do relatively little to save energy, and they're notorious. They usually break after about 1 year. In any case, that market was 420 million in Europe in 2000. There's not much market data on this. And we think that since we cost pretty much the same as these radiator valves, a little bit more, and we offer far more in terms of services, that we will aggressively go after this market, and I think we'll be able to achieve appreciable market share. Future markets, the RadLab system is amazingly versatile. The digital network that we set up, you can send whatever data you want over that network. And the control system is just analog in and analog out. So we can connect whatever sensor we want to that, and thus, if we want to, and if it makes sense for us in the future, we can move into the building automation market, which is huge in the US. And our achievements, we have a provisional patent file. That patent protects us in terms of, it covers the control system, monitoring temperatures and feedback to the fan, as well as the ability to transfer that data wirelessly around the room, around the building. We also built a proof of concept for my apartment. This is a picture of that. These are the fans. This is the wires. This is actually in operation. When we were coordinating a pilot program with Columbia University, and they were very, very excited about this. They said they've been looking for something like this for a long time. It's literally what they said. And they're probably so excited because in 2006, they committed to reduce their carbon footprint by 30% in 2017. It's an extremely aggressive commitment. And to be able to say that we can cut down on 15% of the emissions due to heating oil is pretty significant for them. They're also the second largest landowner in New York City, so they are a very good customer now. The next steps, we're seeking funding for hardware and software development. The cost for those 600 pilot study units is going to be about $30,000. And we're seeking partners for strategic deployments. Thank you very much.
Landlords in New York City, or having lived there, and I remember apartments, are notorious for being cheap.
Sure.
And you want them to now adopt a new technology and sort of re-innovate their design. What's your value proposition to them, and how are you going to get them to sign on, given their buying behavior?
Sure. So I think that that data set that we're going to collect, showing that this actually saves money, is going to be part of it. A lot of the buildings in New York City, the landowner building owner pays for the heat, and then kind of charges more to the customer. And giving them a system that lowers their heating costs should be pretty nice for them, as well as making the tenants much happier. I think a common complaint for tenants is that the apartment's like super hot or super cold, and I'm sure landlords are sick of hearing that.
Who's going to do the maintenance of these systems? Is it the landlord, or is it your company that would do the maintenance?
It's either our company or it's a company that we partner with. And I don't know what the right answer is yet, but it's not. It certainly can't be the landlord, because I don't think anyone wants to take that responsibility.
So that's the ongoing maintenance?
That would be the ongoing maintenance. There's a possibility of selling these units. We'll have to maintain them. If something goes wrong, we're going to have to make sure it gets fixed very fast. One thing that I wanted to, an extra slide that I'm so glad to be able to use. John is working on a project at Columbia called Enhance. And this is energy harvesting active network tags. And these use kind of the same technology inside of them to communicate. I would assume that you would imagine that the network and that communication is one of the fragile parts in the system. But these systems have data logging devices that have run for a year and a half without any interruptions at all. These systems are extremely simple, and because of that, extremely reliable. So I understand that yes, we have to make sure that they keep working, but we are doing our best also to make sure that they don't stop.
Your target market of the 2 million apartments at 5 or more. What does that equate to in terms of the number of the kinds of radiators that you can actually go on, and kind of boiler systems?
So I'm just using the estimates that I read about. So 2 million apartments, if they're the average size is 700 square feet. So I assume that's about 6 million enclosures. In the meeting with Columbia University on Tuesday, they mentioned that they're really interested in this primarily for steam-fed single-pipe radiators, because you cannot control how much heat goes anywhere. And that's actually the predominant technology in most of the buildings in New York City.
So you're limiting, I'm guessing that your customer is only building owners and not end consumer.
Yes, I think that's the right way to go. I think in the future, it's possible to consider making a consumer product, because it does make you more comfortable, but it's certainly
Are you going to be doing the manufacturing of the enclosure units?
In the pilot study, yes. Later on, we will definitely have someone make those for us.
Because radiators are very different form factors.
Exactly, yes. So to address that, intrinsically, the enclosure that we make is easy to form. This is something that's not really covered in this. So this is an existing radiator enclosure that was in my apartment, and our enclosure is basically bubble wrap. It's foil-faced bubble wrap. It's produced for radiant heating applications, and we take one roll 4 feet wide, and we modify that front plate so that you can put those fans in. The fans can draw from the front, from the top of the enclosure, and that's just one piece. And then we take that piece, we stick it in the front of that radiant enclosure, cut it to size, and then we put bubble wrap around the rest of it. And so that front piece is large to begin with. It can fit, I think, almost any enclosure you can imagine. Just cut it down to size, and then you have to put the back part on. Is that clear enough?
What's the mechanism by which you use the data if you do the data transfer to the boiler? Because the boiler inherently doesn't have the control system yet.
Sure. We'll put a control system in it. I don't have a lot of experience with HVAC systems, but from what I've seen, it's usually just a 24 volt signal that turns it on. And so we will build a device that, in these mesh networks that self-form, you need one device that's actually like the home base. So we'll provide the home base in the basement that interfaces with the boiler and does all that control. One other part of what we're trying to do is figure out if it's reasonable to get internet access to all these home-based systems, because being able to remotely access them will cut down dramatically on costs, and also we'll be able to know immediately if there's some problem with the system or some problem with one of the units.
Any final questions, judges?
Thanks.
Okay, the judges are going to deliberate now to pick the grand prize winner. After that, we'll be back for the formal award ceremony, so please stand by.